support. So we'll go ahead and get started. My name is Scott Fowler. I'm the product manager of Tecplot 360. I've been here at Tecplot since 1999, so quite a tenure here, and a good representative to be your expert today. I do want you to participate in the webinar, so if you have additional questions that we don't answer during the slide portion of the webinar, please feel free to ask them, and I'll get to them at the end of the webinar. This webinar is being recorded, so you will be able to view this afterwards as well. It's going to be available on our website in a few days, www.tecplot.com/webinars. So today's agenda, number one, please do visit our website. We have a lot of great information there. We have a really good knowledge base. So a number of the questions that users do ask are available in our knowledge base. We have a pretty good search tool available on our website. And that search tool, the first time you use it, goes through our normal website, but then it will ask if you want to search the knowledge base as well. So do take a look there. There are some resources, some scripts, Python scripts and macros that I'm going to be sharing today or showing today, and those are available at www.tecplot.com/webinars. So if you go to that link right now, you can download the contents there. So I'll just drag the web browser over here. So you see I'm at tecplot.com/webinars. If you scroll down here to the bottom, you can download a zip file. It has a number of Python scripts and macros that are going to help answer some of the questions today. So you can use those for resources and follow along a bit also with the layout and data set that I shared. This data set, vortex shedding, is also available in the Tecplot 360 installation as one of the example files. So I'm going to answer questions today about macros, Tecplot, a little bit about MATLAB and how we interact with MATLAB or can interact with MATLAB, and then dealing with frames and styles. So first question is, do you have any tutorials on using Tecplot macros? Well, first off, for those of you that may not know, a macro is a way to automate Tecplot 360 using a proprietary language that we developed a number of years ago. And a good place to start learning macros is go to the Tecplot documentation. We have a scripting guide available on our website. It's also available right in the user interface. If you just click on the scripting menu, you can see macro scripting guide second from the bottom, and also try recording the macro directly. That'll give you a good head start and give you a good idea of what the API looks like. And if all else fails, contact our support staff, support@tecplot.com. We're available in the United States, 6:30 a.m. until 5 p.m. Pacific time, and we also have support staff in Europe during normal business hours there. So please do contact our support staff either in US or Europe, and we can help you get started. What we find is with when people want to use macros, it's almost each user has something very specific, so it really is kind of hard to create a specific tutorial. Okay, and do you have a tutorial using Tecplot? So again, if you're not familiar with Tecplot, this is our Python API. It's available when you have a Tech Plus license, so that's Tecplot under maintenance. This API will work. We have full documentation at tecplot.com/docs/pytecplot, and that's also available linked in the user interface. So if you go to the scripting menu and right at the bottom, I'll back up one slide here, right at the bottom, Tecplot guide will bring you to this Python documentation. And you can see from the links here, we have installation, quick start, examples. So this will give you a really good head start. You can also record Python scripts and again, use our support staff for help. Okay, and here's where I'm going to go into some specific macro and Python code to show you how to do some things. So we had one user ask, do you have macros that read and edit different time steps to produce transient plots? And we don't really have anything in the examples, but in the handouts or that download that I referenced earlier, we have a couple of macros in there. So here's one. This is called the export overtime MCR file. And this uses the Tecplot macro language to first find out how many time steps you have in your data set. And then it loops over those time steps. And then at each time step, we set the current time step, and then we export an image. So that's a really simple explanation of how to loop through time. And we do have documentation for this extend time MCR command in the user's manual in the Tecplot documentation. Okay, and the same sort of thing can be done with Python pretty easily. You see the format is a little bit different. Now this uses a pure Python API. So here in Python, we're grabbing a handle to the plot. So a plot object would be like your 3D plot or 2D plot, XY plot. And then from the plot, we're asking how many solution times there are. And then we're going to loop over each of those solution times, and we're going to set the current time in the plot and then export an image. So again, Python, really powerful. And if you want to do something a little bit more fancy, you can use plot max over time.py. This is also available in the handouts to say extract the maximum velocity or maximum u velocity here and plot it over time. So let me just demonstrate how this macro works and showing you with one of those data sets. So here I've opened that layout, vortex shedding.lay, and from here I want to create this plot that you see in the lower right, which is this max u velocity over time. So we don't have a built-in function for this in Tecplot, but pretty easy with the macro, or the Python script. So first I'm going to go to the scripting menu and say Tecplot connections, and make sure that accept connections is toggled. So this is going to allow a Python script to communicate with a live running Tecplot 360. And let me just bring my command window over here. And in here, I have plot max over time, and I'll just execute this Python script. And you'll see that it's connected with Tecplot. Now it's going to extract the max u velocity from each time step and plot over time. So now I have these two plots that you can see in a single view. All right, let me just dive into that macro or the Python script a little bit to show you how that script is written. So the first thing we do is we import the Python module Tecplot as TP. So we give it a little alias for some shorthand. We're going to connect to a live running Tecplot 360. And then we're going to suspend the interface, because each Python command is going to cause the Tecplot 360 user interface to react, but we want to quiet the interface. It'll speed up execution time a bit when you're connected to the live running 360. Then we're going to get a handle to the data set. So in this case, we had the vortex shedding data set loaded. From that data set, we're going to loop over all zones in that data set, and we're going to create a list of two valued tuples where each tuple contains a solution time and a max u velocity. And that's done by this. So for each zone, we're going to ask the zone for its solution time, and we're going to ask the zone for the maximum value of the UMS variable. So this creates a list of values, and then we need to plot those values. So we're going to do that in these 6 lines. So we're going to create a new frame. In that frame, we create a new data set, which we give a name, and we tell it that it has 2 variables, t and u meters per second. We're going to add a zone. This is a single I-ordered zone. Line data is best represented as an I-ordered zone. And then we're just going to stuff those values. So the first element of this 2-valued tuple is time, and that goes into the t variable. And the second element of that 2-valued tuple goes into the u velocity. And then we switch that to an XY line plot and activate it, and then we have our plot. So again, this script is going to be available at that download link in tecplot.com/webinars. So that's a quick script to extract the maximum value over time. All right, next question is what data formats are compatible for converting Tecplot files to MATLAB, and can Tecplot interact with MATLAB directly? Well, excuse me. MATLAB, we don't have a direct interface to MATLAB. That said, there are some utilities available out there. The first one is a MATLAB script called mat to Tecplot.m. And you can get a hold of that. You can see information about that script at this link here. This is a blog post that we put together, and it references a thread on CFD Online where the author of this script has posted regular updates. You see by the asterisk here, the author is a gentleman by the name of Wen Long, a former employee at Pacific Northwest National Labs, and also a former Tecplot employee at one point, and he's been a long-time 360 user. So he has quite a bit of knowledge about the Tecplot data model and the MATLAB data model. So that's a nice utility that you can use to get MATLAB data into Tecplot file format. Another method is using the Tecplot's TechIO library. Now this is a C library that can be loaded into MATLAB using some MATLAB magic to access C libraries. And this can be used to read and write SYSL format. It can be used to write the PLT format as well. And we have a blog post and a webinar done by an employee of ours, Devin Simpson, and she did a nice job on this webinar. So if you want to export data from MATLAB, you can use the TechIO library to wrap our TechIO function calls to write data that way. Okay, another question was, how do you convert .tech files to DAT files using macros? So this was an interesting question because .tec is not one of the standard extensions that we use or promote here at Tecplot. This is a file extension that has been kind of adopted by the greater Tecplot community. So let me go over some definitions here first. So the file extensions that we promote here at Tecplot Incorporated are .plt, and that represents the Tecplot binary format. .dat represents the Tecplot ASCII format, and .szplt represents our newest binary format, which we call Tecplot subzone load on demand, which allows you to load very, very large volumetric grids with very little RAM. Now, the non-standard formats that have been really adopted by the community are .tec, which is often, I've most often seen this as an ASCII format, and .bin, that's most often seen as a binary format. So I interacted with this user and asked for more information, and in their case, they actually had a .tec file which was in binary format. So they were really asking, how do I switch from binary to ASCII? And most of our users say, well, how do I switch from ASCII to binary? Because binary is much easier to load or faster to load. ASCII is nice to use if you do need to bring it into a tool like MATLAB or Python. Of course, using PyTecplot, you can load binary data directly into Python, so no need to switch to ASCII there. Okay, so question is, how do you convert from ASCII to binary? Well, that's really easy. You can use a utility called preplot. This is included with Tecplot 360, and it's housed in the bin directory underneath the Tecplot installation. You just pass it an ASCII file, .dat, and tell it the file name that you want as an output, and it will do the conversion for you. A note about ASCII data: whenever Tecplot 360 loads an ASCII file, we actually convert it to binary as it's being loaded. So it's going to be in your best interest if you need to load that file over and over and over again to do the conversion once, and then you're going to save yourself time overall. Now, this specific user wanted to convert from binary to ASCII. Well, we don't have a standalone utility to do that, but you can do it using a macro. I've created a macro called binary to ASCII that's available in the handouts at that download link, and binary to ASCII.py, which uses our PyTecplot language. So this is the simplest case using Python. You just load the data using Python and then save it out as ASCII. So it's really just 3 lines of code there to do the conversion. With a macro, it's a little bit more verbose, but similar idea. So I'll just drag this in. So there's just a read dataset command and then a write dataset command. So from the command line, you would just call tech360.exe and pass this macro. You do need to pass the file names. They need to be hard-coded in here, which is one of the nice advantages of Python, is you can pass those in as command line arguments. All right, so what's the best way to place streamlines and streak lines? The on-screen tool can be difficult to use. I also interacted with this user. So the real complaint about the on-screen tool was this user was trying to create an arc of streamlines, which is not possible on screen with Tecplot. We have a what we call a rake tool, which does just a straight line. Well, if you want to define that arc, the best way to do it would be with Python again. So here is a couple example lines of code where you get a hold of the stream trace object associated with the frame, and then you can add stream traces at specific XYZ locations. So here I'm adding a streamline at 0.5, 0.5, 0.5, so that's XYZ, and I'm telling it to be a volume line. So you could then quite easily create an arc by having multiple of these add commands. And then here's the equivalent in the Tecplot macro language. One thing you'll notice here is in the macro language, I specify the stream direction as both. The Python layer and the macro language have different defaults for stream direction. Stream direction in Python defaults to both, whereas in the macro language it defaults to forward. So these two lines are actually equivalent at this point. Okay, can I load a saved frame style without the position? For example, I want to tile frames and then save the style in the upper left plot and load it in the lower right. The answer is yes, but not directly in the Tecplot 360 user interface. And let me just go through a quick example here as well. So here I have Tecplot 360, and let's say I have this upper frame here. Let me delete this one, get it out of the way. And I want to copy this frame style to a new frame. So the first thing I'll do is I'll actually create a new frame, and I'll switch it to 2D. Now I can quite easily click on this upper left frame and say frame, save frame style, and then come over here and say load frame style. Well, when I load that frame style, it's going to also copy the frame size and position. So it's going to be overlaying in this original position. Well, I want to retain the position. So one of the other things that I've put in the handouts is another macro file called copy frame style. And what this does is it will register a couple of commands on the quick macro panel, and I'll show you how this works in just a minute. So the copy frame style, it will write a style sheet to a temporary directory. If you want to use this macro, you may have to update this absolute path. And then it will read that style sheet back in, with the magic being this bottom line, include frame size and position, no. So it will load that specific frame style, but it will ignore the frame size and position. All right, so let's show you how this macro works. So I'll just drag and drop this macro on the Tecplot 360 user interface, and you see two new entries showed up here in the quick macro panel. I'll just click on this frame and I'll say copy frame style. So I'll select it and hit play, and then I'll select this new frame. And again, I can either hit play or just double click. So I'll double click here, and now I have the same frame style. So this is one of those macros that I use actually pretty often. So if you want these macro functions to be persistent and always available to you, you can put them in the tecplot.mcr file in the home directory of Tecplot 360. Now, if you're in an environment where, if you're in a Linux environment and you're sharing that installation with a number of people, you can also put a .tecplot.mcr file in your Linux home directory, and then you won't impact other users on your network. And there's information about that in the Tecplot user's manual. So look for tecplot.mcr in the user's manual, and you'll see how to register macros in the quick macro panel. Okay, back to the PowerPoint. Okay, how do I share data across frames without having to reload the data? So this is a good question, and it can be a little bit confusing in the Tecplot 360 user interface. So let me again bring up Tecplot 360, and I'll open a recent layout. So here I have two different data sets. I've loaded the vortex shedding, and this is the Onera M6 wing, which is included in the Tecplot 360 installation. So let's say I want another frame of each of these, but I don't want to reload the data. The problem with reloading the data is then we have a copy, we have multiple copies of that data set instead of sharing the data. So if I were to load this again, I would have, I'd increase the RAM required to house all the data. Furthermore, if in one of these I've calculated new variables, extracted slices, reloading the data forces me to redo that work. Whereas just sharing will retain an exact copy of this data with very little increase in RAM. So to make things a little bit easier to follow, let's rename a couple of these frames. So I'll go to Edit Active Frame, and I'll say Onera wing. And on this one, I'll change this to vortex. Okay, so a couple of ways to do this. One is I can just edit, copy, edit, paste, and now I have another exact copy of this data set. So that's a really easy way to do it. You save all the style, but there's another way to do this as well. I can create a new frame, and I can just flip the plot type. So the question is, which data set is this going to inherit? And it's going to inherit the frame that is at the highest entry in the frame order here. So this is going to inherit the Onera wing when I flip to 3D. Now let me create one more frame. And now I want this to inherit vortex shedding. So I'll just say, bring this to front, and then I'll click on this empty frame. And this one that has no data in it will inherit the data that's in the topmost frame, or at least it should. So let's go to 2D, and then we can bring this to front and see that it inherited the vortex, because the vortex was the highest order in that frame order with data. So again, if you want to share data between two frames, it's either select a frame and do copy paste, or you can create a new frame and just change the plot type, making sure to know which is the highest frame in the frame order. Okay, how do I display time evolution in, say, 6 to 8 frames simultaneously with length scale? Well, I'm not exactly sure what the user meant by length scale, but here you can see that we can use frame linking to link across. Here I'm doing it just in 2 frames, so I have a zoomed out view and a zoomed in view of the same data animating through time. And length scale, again, I'm not sure what you meant there, but here I've put a piece of text on the plot, and this uses a piece of what we call dynamic text, which displays the solution time. So again, a quick demo here of what that looks like. Let me just open this layout again. We'll add a piece of text here. We'll just say time, colon, and then the trick is solution time. So that's our way of indicating to use the time as dynamic text. And if you go to help, you can find all sorts of information about different dynamic text that we have available. All right, so this is the last question that came in from our users that we had time to get into the slides. This is a tough one for me to answer. You know, I'm trying to decide between Fieldview or Tecplot. Well, you know, I'm the Tecplot 360 product manager, so I'm going to say always use Tecplot 360. But you know, seriously, both are really great products for visualization and analysis of CFD data. The users that I interact with, now they may be a biased set because most of them are Tecplot 360 users, find Tecplot 360 to be easier to use than Fieldview. But we do have a wider set of plotting capabilities. So Tecplot 360 is really known in the industry as having the broadest set of plotting capabilities with 2D, XY, even polar line plots. Our Python API is really fantastic, as you can see today, for extracting information from your data set and creating new plots from that. So if you are in a situation where you need to compare simulation data with test data or have just generic measured data, we're a really great tool for that. Now, that's not to shortchange our 3D and large data capabilities. We've made a huge investment in our 3D plotting and our performance with very, very large data sets. So we have a number of users that are using Tecplot in HPC environments, running Tecplot in batch mode using Python, or using just regular Tecplot 360 with macros in HPCs. So you know, Tecplot 360 is really a great tool. If you have a specific data set that you're trying to post-process and trying to decide between the two tools, please contact our sales team, contact our tech support team, and we'll help you out. We do have a 5-day free trial that you can download from our website to give it a test drive, and we do encourage you to interact with our staff here. They're happy to help you out. So if you have any specific questions, please start typing them now, but that's the end of the prepared content for today. Again, this recording is going to be available on our website, tecplot.com/webinars. We have a number of tutorials available at the videos link. And if you want a little bit of an online self-paced training, you can go through our certification. You get a nice fancy certificate emailed to you at the end. That's tecplot.com/cert. I'll wait just 30 seconds here for a couple of questions to come in, and thank you for your attention today. Yeah, it looks like one question is coming in, so I'll hang out just a little bit longer for that question to get typed up. Okay, so the question is, when I try to put text with the LaTeX interpreter, it shows an error message. We did add I can't exactly remember what release this was, maybe one of the late 2017 ones or mid 2018, we added the ability to add LaTeX text. So I'm not a LaTeX expert myself, but let's try to fumble through this. So I'll say $alpha and hit LaTeX. It has to be a backslash. Let's try that. Yeah, there we go. And we'll bump up the size here to say 30. So you can see I now have alpha here. So with LaTeX, it does require that you install your own LaTeX engine. So we didn't embed a LaTeX engine in with Tecplot 360. So it's dependent on you having your own installation. We've used MikTeX and I think TechLive are ones that we've tested against. We've tested on Windows, Mac, Linux. So make sure that you have a LaTeX engine installed. There is also in the Tecplot 360 installation, there's a file called, I think it's tecplot latex.mcr. which has information about the Tecplot or the LaTeX modules that you want to load, and paths to where the LaTeX engine lives. So we do have information about that also in our user's manual. So yeah, please take a look at that. And my support staff here is helping me out. If you go to our website, tecplot.com/2017/11/16, LaTeX-fonts. So let's just see if we can bring that up in the browser to show that to you. LaTeX fonts. Yeah, so quick little video tutorial on getting that set up. So again, you see the resources, MikTeX, Tech Live, and information about the where to find it in the user's manual to find setup. So okay, it looks like let's see, one more question coming in. Okay, it looks like that answered the question on LaTeX, so great. And yeah, give it a try, and if you do have any problems, contact our support staff. They'll be able to help you out. And then can we share a copy of the slides? Sure, we'll create a PDF of the slides and update that zip that's on the website. So okay, well, thank you all for your attention. Have a good holiday, and feel free to contact tech support anytime when you have more questions. Bye-bye.